Okay, so I'm hoping everyone's gonna. It's gonna take another 40 minutes. Okay. All right. So these problems right here. So we already did the first two, A and B, on our warm up. So A and B are already on the warm up. So we know that this first one is supposed to be 84. The next one's going to be, was it 12 what?
12.5.
There we go. Now, I'm going to show you guys how to calculate these next ones. Because I was getting worried a lot of people don't know how to use the calculators. So that's actually going to be a huge issue here. So, right here, we're going to enter every place that there's an X on letter C. We're going to put a 5. So I'm going to go parentheses, 5, close, and my power is square, so I go right here. The next one's going to be plus 7 times 5, close, right? Minus, parentheses. Please don't be cutting right now because I need you paying attention and actually doing your work. So, this is the part where you have to pay attention. And I know you're not cutting right now because it has an exponent of 1/3. So I have to do this. So I go exponent. So right there, brings me a little thing there. And I go 1 divided by 3. And then I arrow over. So I can enter my next number, which is plus 2. So I end up with 60.29. So everyone in your calculator right now, I should see everyone's calculator. Everyone's calculator should be doing this. Dang it. Did it again. Yes, you can. This thing is actually super, super smart. This one right here. This is 28. Is that what you're saying? Yeah, that one's 28. So I'm asking people nicely. Everyone should be entering this in the calculator to actually get some answers here. So I gave you and I showed you guys how to do it. Everyone should have 60.29 on that last one. Now, on this next one, so I want to see you guys do the same thing on the next one. So you have to do it. So please, right now, you as a person that is not cutting, because I've asked 4 or 5 different times to not be cutting, to actually do part D. Did you do D? Okay then. As long as you're not checking your phone or you got your earbuds in, because you're too cool to work on any of this stuff. What's my answer for D? 0.6? I'm trying to see it. actually, I am looking at your calculator now.
Oh, yeah.
Uh-huh. Oh, yeah. Mm-hmm. Let me see. All right, so, all right, hit okay. Did you hit okay? Yeah, because you're not supposed to put x's. You're supposed to put wherever an x is, replace the x with 5. Huh? No, you only did it for the first one. Yeah, try it again. So, for this right here, we should be coming up with, all right, Trinity, all your thing is in the exponent, so you got to fix yours. Everything is as an exponent. So redo it because it has 5 squared, then everything else is an exponent. Yep, that's what you should come up with.
I got that first, and then I literally got that first.
All right, if you put the variable x in there, it's not going to be defined. Replace all your x's with the 5.
Because you see how you put a decimal after 8.36? Or not a decimal, but a multiplier.
Okay.
That's a minus.
All right, so we're going to move on from this one.
That's what I got at first.
All right, so I need everyone back on this, please. So for this problem right here, so we're going to take a look at this next part. So the graph identified the relative maximums and minimums. Brooklyn, all your stuff is in exponent right now. So back it up to all the way to the first 5 on your thing, on your exponent. Right there. Oh, close it. Exponent. 5. Or is it 3? Yeah, there you go. Now you're good. You had to arrow over to get to the next one, okay? All right, so now for this one here, we're going to talk about relative maximums and relative minimums. Relative is not absolute. Absolute, or another word for it would be global. So this one right here, as a maximum, goes up to infinity, right? It keeps going on this way right here. It goes up to infinity. Down here, it goes down to negative infinity. So if I would say absolute, this would be a negative infinity, and a maximum of positive infinity. But relative means that just in between there, little bumps. So this spot right here is going to be considered a relative maximum. So that is a peak somewhere in between my endpoints. So it's going to go up and then back down. So that's going to be a peak right there. So I'm going to have a maximum there. So let's say that is going to be at -3. So we're going to have a maximums at -3. So x -3. So the ordered pair on that one would be -3, comma, and that looks like it goes up to 1. And just say 1. And do we have another one where it comes up to a peak? Where's that? Give me the x value. At 1, right? Okay, so right here's another one. So it's going down and back up to this point right here. So it's going to be x is positive 1, and my coordinate would be 1, comma 0. So this one is another peak right here. That's going to be another peak. Now let's talk about the minimums. So the minimums are where it has a little valley. It goes down. It goes down, then comes back up. So let's take a look right here at negative 1, right? So it's x equals negative 1, and my point is going to be negative 1, comma negative 1. So that's one of my relative minimum. And I have another one at x equals, let's say 5. Yeah. Let's say x equals 5, because that's going to be this one down here. That is a relative minimum over this interval. So my point is 5, comma negative 9. Make sense? Okay, good. Now, we're going to talk about absolutes now. So I'm going to tell you what the difference is. So an absolute, absolute max is going to go to positive infinity, because this goes all the way up to positive infinity. And an absolute min would go to negative infinity, because it keeps going down right there. So I don't have an x value, because the x value, as it keeps going this way, it keeps going up, doesn't it? So it's, the x value keeps getting bigger, and it also keeps going bigger. X value right here, as I get negative, big negative x values, I get negative y values. So it goes down to negative infinity. Now, before we actually do this next part here, I need to give you guys a little bit of direction, because a lot of people forgot what these are. So a degree that is the highest variable exponent. The leading coefficient probably yeah, I probably forgot it. Goes somewhere in there. O-N-E-T. E-X-P-O-N-E-T. Okay. Either way, leading coefficient. The number in front of the degree. And constant. Has no variable. All right, let's see if you guys could actually pay attention and read on this one. I gave you guys the directions, and I gave you guys the information. Tell me what these two are. So on your paper, I want you to fill out the f of x and the g of x right now. On your paper. On your paper, you're doing the f of x and the g of x. I know Jonathan does not have his phone out in front of him, right? super easy. I think you're overthinking it. What's it say? Go ahead, Brooklyn. What's it say for the first one? You got the wrong one. Oh. Where'd they put it? It's stapled. It's right there. Okay. Yeah, that one's a practice. Brooklyn, what's it say? You good? Yeah. Fine. All right, so it says degree is the highest variable exponent. Let's look at the f of x. What is the largest exponent? 2x to the third, right? The exponent is 3, right? The highest variable exponent. So this is, it's a 3. Leading coefficient. The number in front of degree. Just 2. The constant. Like I said, this is not meant to be tricky at all. All right. G of x. What is my degree? 20. Very good. What is the leading coefficient? 8. Not 0. Where'd 0 come from? I don't know.
The 2 of x, because it doesn't have anything.
That's a 2.
Oh, that's what
Yeah. All right, what's the constant? -6, very good. All right, you should have enough information now. I want you to finish the next 3. So you're filling in the last 3. Yeah, you can, but Pacho. Yes. Do you want me to send someone down there? No? Okay. All right. Thank you. Bye. Anyone want to take a trip up to the registry? Wow, me. Wow. Whole bunch of me's. Oh, whichever me gets up here. Registration. Some kid named Carlos. All right. So let's see. Right here. What's the degree of this one for h of x? 2. What's the leading coefficient? 1. Very good. 1. And constant?
5.
Very good. What is my degree here?
1.
It's 1. It's implied. If there's a variable there, there's an exponent of 1. What is the leading coefficient?
3.
-3. Constant. What is the degree?
I put 0.
It is 0.
0, 0, and 10.
It is 0. The leading coefficient is
0. That's nothing.
10. And then I'll show you why a constant is also 10, right?
It doesn't have.
I'll show you. Because if this was 10 x to the 0 power, anything to the 0 power is 1, right? It would be 1 times 10 is 10. So it is also the leading coefficient, and it's also a constant. If I were to, hold on, I'll show you. if I were to write this like 5x cubed plus 2x squared minus 3x plus 4, then plus x to the negative 1. So this is actually technically to the first here, and this is x to the 0. So 3, 2, 1, 0, then over to negative 1.
I get that, but there is no x there.
You're right, it's not.
So how
Anything to the 0 power is 1, right?
Yeah.
Yes?
Oh.
To the 0 power, so no matter what it is, it's x to the 0, so the coefficient's 10. So I could write this as 10 x to the 0. So the degree is 0, the leading coefficient's still 10, and then it's still a constant of 10. Okay, means the same one on this one. All right, so let's take a look, because Jonathan's playing on his phone, so we're just going to move on. Hey, that reminds me, you guys got a quiz on Friday. What? I've been trying to give you guys quizzes every week. Less, smaller pieces, so you don't have to try and cram in 4 weeks worth of knowledge into, one test. Yeah. Try to make it smaller, make it a little bit easier. All right, let's take a look right here. Huh? Yeah. Wait till Jesus comes back, or Jose. Yeah. All right. It says write equations for the polynomial whose graph have the characteristics listed when plotted on the coordinate plane. A first degree polynomial. So what am I going to write for that? First degree.
I'm not sure. Oh, wait. First degree is. That will be 2.
Just x to the 1, right? X to the first, right? Like that. With the leading coefficient of 2. So what do I do with the 2? Put it in front of it. Very good. Put it in front. And a y, and intercepts the y-axis at 8. Plus 8. That's it. A second degree would be x squared with a positive leading coefficient. Doesn't matter. Something positive. Let's put a positive number there. And intercepts the y-axis at 3. Third degree polynomial.
You just put whatever number you want.
And a negative leading coefficient. I heard negative 7. And intercepts y-axis at a negative value. A fourth degree polynomial whose graph never crosses the horizontal axis.
Okay,
I
so
want to say 0, but I'm not.
7x.
To the fourth power, is that what you said? Yeah, you said to the fourth power, right?
Sure.
She's going next.
Then plus 3.
All right.
Because it can't go down.
It's not going to go down. So I'm going to show you guys a graph on this now. I'll show you guys here. I'm going to show you the graph on this because this one is a little bit complicated. So I'm going to show you the graph. So if I go x to the fourth and add a number, you said plus 3. Does that blue line cross the x-axis?
Nope.
No. But what if I change that? I'm going to go tab, and I change that to be a negative. So minus 3. Does that cross the y-axis now?
Yes.
And now crosses the y-axis. So for this one, I just need it to be a positive number there.
Wait, I thought it was supposed to cross the x.
Positive x-axis, yeah. It's not positive. This one is, but that's what I'm saying. So I need to,
Oh, it's because you said x-axis. That's what I was confused.
so plus 3. All right, so we got that. So that's a good one right there. And so everyone else, zoning out, playing on the phone, and just doing whatever they do. Now, this next one right here I think is pretty interesting. Explain how it's possible to change this into a 30th degree polynomial. What's the highest degree? What is the degree of this polynomial right now? It's 15, right? And to make it into the 30th, not change it, I got to do something to it to make it 30. Multiply by 2, but the problem is if I just multiply, that would only change the number out front. So I'm going to show you guys something here. So we're going to have, if we have x squared times x cubed, is not going to be x2 plus 3, which is x to the 5th. So if I'm multiplying, I add exponents here. Sorry, too far. If I multiply, I add exponents. Oh, crap. I wrote it in the wrong spot. Multiply, I add exponents. Now, if I do this, if I say that it's going to be x2 times x2 times x2 times x2. That would be the same as saying x to the 2 plus 2 plus 2 plus 2. How many 2's do we have there? I have 4 of them, right? So I would have 4 of these. So another way of writing it would mean x squared, right? And I would have 4 of those. It's power to power. So I have 4 of these, right? So I'm doing this. 2, 3, 4. This says I have 4 of those, which eventually will give me x to the 8th. So what do I do with my exponents, my power to power? You multiply if you get power to power. So let's go back to this concept right here. So to make this into 30, I need to do what? Multiply by 2? Close. Go back to what I said right here. You have your exponent, right, of 2. I would take this whole thing, 12x to the 15 minus 10x squared minus 7x to the 5th plus 8x squared plus 13. And all this right here needs to go to the second power. So when I do this, if I was to expand this whole thing, I really don't want to, but my leading coefficient would have a degree of 30 because it's 15 times 2, but it's also going to be, the leading coefficient here is going to be 144. It's 12 squared, so it's going to be 144. But if I expand it, I have to distribute this over and over again. I don't want to do it, though. It sucks. All right, you guys ready? Okay, so now, okay, so I'm going to change this up. So due to the lack of having the time, we're going to do some interpretive dance. You guys all seen Squidward, right? Yeah. Okay, so we're going to do some interpretive dance. Okay. All right, so now, so those people following along in YouTube land, just pretend like you know what we're doing. All right, so if I was going to do a straight line, I would grab someone's phone and I would throw it as far as I could.
That's fine.
Put it away. Time 4. All right, so straight line. So for you guys, straight line. How would I show a straight line? Right here, right? Both hands. Let me see it.
Your hands are not even straight. One's higher than the other.
And this coming from you that's not even trying? Come on. You get an F for effort. Okay. All right. So everyone, this is linear. This is an x to the first power. Linear forms a straight line. Linear, straight line. Okay. So now, let me see if I can line up with you guys. All right. So now, if it was a positive slope, which way would it go? Right here, right? This is positive slope. So when I turn around, I should see everyone right now, right?
Sure.
Negative slope. Negative slope. It's going down, right? Because we read from left to right. Okay? I'm not seeing hands over here. Thanks. Okay. All right, everyone go ahead and put your hands down. I only got 2 people that need to participate. Show me a negative slope. Wrong, try again. Show me negative slope. No, you didn't. That was positive. No, because you read from left to right. That's negative. Now show me negative.
Okay, chill out.
Okay. It helps. It helps. Trust me, even during the test, at the end of the year, you will thank me. You'll look around, you'll see people doing this stuff. I have calculus students that still do this when we're talking about it during a test. All right, so now, next thing is going to be an x squared. X squared makes the shape of a parabola. I know people are not packing up right now because I ain't done.
Of course not.
Yeah, he's not done. Y'all listen to him.
Sit.
I was talking. Oh, Jesus Christ.
Okay, an x squared is a parabola. So now, with your hands, show me parabola.
Show you what?
Parabola. It's a U. Up, right?
I knew that. I was.
Everyone, let me see it. Let me see. Everybody. Don't make me call you out again. Okay, please.
Oh my goodness.
Thank you. Thank you. Now, negative parabola. What would be a negative parabola? There we go. Negative parabola. Very good. Negative parabola. Now, the next one. Listen up, please. The next one is going to be an x to the third power. X to the third power. Because we started with first power, then we did second power, now we're doing third power. So what do you think it's going to be? Wait, he's got it there. Alright. So it should be like this. It starts down low and it ends up high. So there's a positive. And a negative would end down. So let me see that negative third power right now. We have to get to this next one too. Everyone, negative third power.
Oh my goodness.
That's positive. Let me see the negative. Thank you. All right, good. Now, x to the fourth is the part that I was trying to get to here. What do you think x to the fourth? Same as a parabola, it just goes up faster.
I like this.
Yep, it just goes faster. So x to the fifth.
Like
X to the
this.
fifth, like this, it just goes up faster. X to the sixth.
All right. Okay.
X to the seventh. Odds will actually start down and go up.
That's fine.
Okay, where a positive or an even will always end up. Okay. Yeah, it gets tighter. It goes up faster. All right.
Can I leave my notebook so you can grade it?
Go ahead, you guys. I'm sorry. I had to argue with people to get them to do their last thing.